So continuing with these Newton's laws forces problems, a car with occupants has total mass 800. Car is at rest. So we have u is equal to 0. I'll just write the variables over here. When the engine is started, the total resistance force is 350N. Resistance force, we call R, is 350 newtons. If the car reaches a speed of 10, so we're told u, well, my final speed of v is equal to 10. After covering 50 meters, s is equal to 50. Find a. Okay, well we have u, v, a, and s, so v squared is equal to u squared plus 2as is going to give me 10 squared is equal to my 0 plus twice a, and I've covered 50. So 100 is equal to 100a. So a in this case is 1 meter per second squared. Now we're asked for the constant tractive effort, this T. So my little diagram, I have my T, I have my resistance. So it's going in this direction. So T minus my resistance, 350, is equal to the mass, 800. And it's in kilos, just double check your units, 800 kilos by A, which is 1. So T has to be 1150. I can't do my fives today. 1150 newtons. Question 8. A bullet of mass 50 grams. So I'm just going to write that mass is equal to 0.1. Again will be 100. So it's 0.05 to give me my 50 grams. And it's traveling horizontally at 200 meters per second. So the speed of this bullet is 200 meters per second. It enters wood and travels a distance 1 meter into the wood. So it's entering this stump and it's going in here. It's going to stop at this point 1 meter into this big thick stump. So we can say the final velocity is 0 and the distance traveled is 1 meter. So we have u, v, and s, which will enable me to get a. And in this case, it's going to be a deceleration, so it's going to be a negative a. So again, v squared is equal to u squared plus 2as. It stops. Hit at 200. Sorry, 200 plus twice my acceleration, which is what we're looking for, by my distance, which is 1. So we're going to have 200, 1, 2, 3, 4 zeros, 20,000 divided by 2 is going to be my acceleration. That's a 4, not a 2 clearly. 2 squared is 4. So that's going to give me my A, and that's going to be a negative A. So A is equal to 20,000 or minus 20,000. ms to the minus 2. So that will enable me to find my resistance force. Force is equal to ma. So in this case, my mass, which is 0.05, by my acceleration of 20,000, the force in this case is going to be just 1 to minus 1,000 newtons. And then, as usual with these questions, how far would it have penetrated if it was traveling at twice the speed? Twice the speed. So now I have u is equal to 400. Everything else stays the same. It's going to stop. V is equal to 0. We're looking for s. My acceleration is minus 20,000. So it's just putting these variables into the formula that stands out, which is u squared. V squared is equal to u squared plus 2as. We're looking for s. So v squared, it stops, is equal to 400 squared this time, plus twice, minus 20,000 by s. If we didn't have a minus here, we'd have a positive or a negative distance. So we're going to have to divide 16 with 4 zeros, 160,000 by 40,000 to get s. So s in this case is going to be 4 meters. Okay, number 10. A bullet is fired horizontally, and we're given this diagram here. So just set them all up the same. Got our diagram. It's fired horizontally at 300 meters a second. It's going into a fixed piece of wood, which is 10 centimeters long. Here's my 10 centimeters. And it emerges at 200 meters a second. So it comes out the other end at 200 meters a second. If the resistance is 25,000 newtons, find the mass. So we're working backwards in this question. And then we're asked another part here, which we'll come back to. So let's write down our variables for question 10. I can remember them. And I think I did skip 9, did I? I'll come back and do 9 in a second. Okay, so 10. Let's look at 10. So I have my speed. It's going in at 300. It's coming out at 200. The distance is equal to 10 centimeters. Just double check that. 10 centimeters. Now we're dealing in meters here. These are meters per second, so it's 0.1 of a meter. So from that we can get acceleration. We've used this formula a lot in this video. So v squared is equal to u squared plus 2as, and you can see I write the formula each time because maths is about trying to eliminate error, and formulas, writing them out, will help us eliminate error. 300 squared plus twice a. We sometimes will have error by 0.1. Embrace your errors and try to not make them again. So to get acceleration in this case, and we can see that it's slowing down here, we're going to have 200 squared minus 300 squared divided by 0.2, 2 by 0.1 divided by 0.2 is equal to a. So in this case, a is going to be 40,000 minus 90,000, 50,000, minus 50,000 divided by 0.2 is multiplying by 5. Minus 50,000 by 5 is minus 250,000 meters per second squared for my acceleration. So then the second part of 10. So what we were asked? No, we were asked to find the mass, weren't we? So we're asked to find the mass. We've only started this one. And we're told the resistance force is 25,000, aren't we, in this question? 25,000. So that's my minus resistance force. So it's slowing it down. So F is equal to MA. So my resistance force of minus 25,000 mass times minus 250. So it's just 25 divided by 250, 1 over 10 is equal to the mass, which is 1/10 of a kilogram, which is 100 grams, or 0.1 kilograms for its mass. Then we're asked, what's the shortest piece of the same wood which could have brought the bullet to rest? Okay, so if we imagine it's coming to rest, here's my piece of wood. So it goes in, and we're imagining that it's stopping at some point. It's not coming out the other end, and we don't know its length. S is equal to S. But what else are we going to say here? We're going to say its final velocity, obviously, at this point is 0, and we have its speed of 300. My u is 300. We're looking for S, and my acceleration is still the same. It's not going to change. It's my minus 250,000. So VUAS, I'm going to again use V squared is equal to U squared plus 2AS. We want it to stop. So it's the initial velocity squared plus twice minus 250 by s. So 300 squared, 90,000 divided by 500,000 is equal to s. 90,000 divided by 500,000 is 180 over a million, so 0.18 is what a calculator should give here for the distance, and that will be in meters. Go back and look at question 9, and then I'll do 11. Question 9 here, a body of mass 10 falls from rest through the air. I do a little diagram along here. If I do it in red, it will stand out. So we have this body, its mass is 10 kilograms. It's going down in this direction. It's falling through the air. There's always a resistance. And air resistance in this case is a constant 18 newtons. Show in a diagram the forces acting on the body. Well, what's bringing it down? mg is bringing it down, which is 10 g. We've seen this before. And 10g is 10 by 9.8, which is 98 newtons, going down that way. So because it's going in this direction, my acceleration is in this direction. We start with my 98. 98 minus 18 is equal to my F here, my resultant force, which is 80 newtons, is equal to my force. And what are we asked to do here? We're asked to find accelerations. Well, F is equal to ma, so 80 is equal to my mass, 10, times a. So a in question 9 is equal to 8 meters per second squared. We'll try and fit in the distance covered here. The distance covered in the first 10 seconds. S, we're looking for S. We have t is equal to 10. A is equal to 8. It started from rest, so U is equal to 0. So S is equal to UT plus a half AT squared. We're looking for distance, so it started from rest, so I have 0. So I just have a half by my acceleration of 8 by 100. So that's 400 meters in the first 10 seconds. In the next 10 seconds, I need to get the first 20 and take away the first 10. And if we look here, if this is 10, if that's the first 10 seconds is 10 squared, the first 20 seconds would be 20 squared. So we'd have half of 8, we'd have 4 by 20 squared, 400. So we'd have 1600 in the first 20 seconds. So the difference between those two is 1200 meters. 1200 meters for question 9, and that's the end of question 9.